All right, a plane flies 200 kilometers an hour in the indicated direction. The wind is blowing 55 kilometers an hour in the indicated direction. Providing appropriate reference, tell me the plane's velocity, its speed and direction relative to the ground. You can assume standard kind of coordinates of like south, north, east, and west. We all good? Do you understand what I'm asking you to tell me? Begin. 3 minutes. Still a few missteps, so I'm going to run through this briefly. And I'm going to say things out loud purposely to remind us that there's a procedure here. So step one for me was to create reference. I'm going to use south and west. Moreover, I'm going to make this the positive direction and this the positive direction. We need reference. Now, I saw on at least 2 papers people doing this. Is a plane flying that way? I mean, it's not, right? I mean, I agree. You could probably get some numbers that will work, but the plane is not flying this way. So this is not your triangle. And consequently, this is not your triangle, right? Neither one of those really work. They don't really describe what the plane did. The idea is to make a triangle that describes what the plane did. I think you have 2 choices. You could do that. That describes what the plane did. That arrow that starts here and ends here describes the direction of the plane, right? And if you didn't like that one, you could, of course, do that. That'll work too, right? You need to pick one of these. Doesn't matter which one, but you need to create a triangle, and your creation here should deal with reference. Now, because I'm going to use this triangle, because it's the last one that's sitting here, I'm going to draw in my coordinate system so that there's no ambiguity about what the directions are. So I still have my coordinate system in place, but now I have my 2 vectors, and I'll put in my result. Now we're going to go to work, right? Continue the procedure. I have done step 1, which was to put together a coordinate system. Step 2, identify a triangle. Step 3, on that triangle, find the angle of focus that I'm going to use. Label my sides, opposite, adjacent, hypotenuse. And then begin the work of trigonometry. I could write out all of my trig functions. I don't have to. I notice already ahead of time that I've been given 2 sides. Those 2 sides correspond to opposite and adjacent, so I'm going to use tangent of 200 over 55. I can write all of them out. I don't have to. The procedure has steps in it that are a little extra, but we're not just solving a triangle. We have a purpose in mind, and I want to focus on the purpose. This is where I reach that fork in the road, and I suggest that you guys make sure your calculator is in degrees. And I'm going to choose the side part of that fork in the road, and I'm going to take the inverse tangent of both sides to find out theta is 75 degrees. All right? Any question about that? You should keep decimal places here. I'm not going to. I want to get through this, but you should. And this tells me that this angle here is 75 degrees. I'm not done yet. I still have to figure out what h is. I have a variety of methods to do so, but if I continue on with my using the trig to do so, I could say that sine of 75 is equal to 200 divided by h. This will eventually give me my answer, which is that h is 207 kilometers an hour. I could also have used the Pythagorean theorem. 200 squared plus 55 squared, add them together, take the square root, right? That would work too, but also check my work. All right, I have followed the procedure pretty closely. Yeah, I've skipped a few things, but I think we're okay. Any question at this point? I walked around and people had this, but you didn't give me the answer. I wanted the answer. The answer involves these numbers, but it's not exclusively these numbers. The plane is traveling at 207 kilometers an hour at a heading of 75 degrees west of south. And you also could have given me 15 degrees south of west. That's fine too. But provide reference for your angle. Don't assume it's implied, even if there's a picture there. You know, because I have the picture on some people's papers and they still have this wrong. I need to know you can do all of this. All right. To 75, I first had to understand that I had a ratio. Do you understand how tangent theta equals 200 divided by 55? The rest, you have two options here. One, look it up in a trig chart, but you don't have one. But you probably have a scientific calculator that has sine, cosine, and tangent on it. So I need to find the angle when I take the tangent of that angle will give me 200 divided by 55. So I took the inverse tangent of both sides. The result from my calculator should tell me the angle, but that's what I did. Is that enough?
Yeah, that's enough.
Okay. No worries. I appreciate the question. We're going to do sum of vectors today. And sum of vectors is actually fairly straightforward. It's a 3-step process. It is not particularly hard. It involves everything we just did, but everything we just did is something for the context outside this room, except for step 1, which is create a coordinate system that is consistent across your problem. That's here. Your math class has always given you a consistent coordinate system to use, X, right? That's been it for your math class. But for us, this is a 3-step process. You're going to be given a group of vectors. Doesn't really matter how many. You can add as many of them together as you are given. For the time being, we'll probably be only dealing with 2 or 3. But your first step is to convert everything to rectangular. Again, we are adding vectors together. This is a sum of vectors discussion. Step 1 will be to convert to rectangular. We need everything in an agreed upon set of one-dimensional components. That's what that is. So we convert to rectangular. 2, we add together like components. 3, convert your resultant back to polar. 4. That's it. That's the steps. Now, we'll be adding vectors together all year. We have lots of vectors that we work with, and because of that, we are almost always adding vectors together. You won't always do all of these steps. Sometimes they're already going to come in terms of rectangular. And oftentimes we end right here because the components are enough to answer the question. But this is the process of adding vectors together. At the end, you're going to get a vector for an answer, and that vector should be provided with its size and its reference direction. So we're gonna start with a very simple example. We'll see how well you acclimate to it, and we'll see whether we can ramp up the difficulty or we have to stay at that difficulty for a little while. So here's your first example. And I'm not very inventive today. Plane flying at 200 kilometers an hour at 40 degrees. Let's go with south of west. Encounters a wind of 30 kilometers an hour due south. Find the ground speed of the plane. Well, ground speed and direction of the plane. Okay. This is I'm going to say it, a very simple sum of vectors question. Okay. Now, I want you, when you're faced with one of these, to consider what is being asked. It's clearly outlining 2 vectors. I'm going to start by just creating a coordinate system that I can map these vectors onto. So a coordinate system that I can map the vectors onto. I'm noticing where they are, so to make this a little easier to map and give me a little bit of room, I'm going to focus a little bit more on the south and probably there. Focus a little more in that direction too. So this is east and this is west. I'm going to make south positive and west positive. That seems like not an unreasonable thing to do. There are two vectors expressed here. First is the plane, 200 kilometers an hour, 40 degrees south of west. 200 kilometers an hour, 40 degrees south of west. But then the wind, 30 kilometers an hour due south. Suggesting that the plane is actually flying more southerly than perhaps it wants to be. So this is vector 1, vector 2, and the result. I've done just a brief, not to scale, sum of vectors. That's what this is. You add your vectors tip to tail, and the result starts at the origin and ends at the end of the last vector. I'm laying out what our problem is going to look like. Now, to solve this problem, we follow a series of steps. We convert our vectors from polar to rectangular. We add like components together. And then with our result, we convert back to polar. So that's exactly what I'm going to do, okay? One vector at a time. So let's start with the plane. Get this stuff out of there. So I'm going to start with the plane. I already have reference. So I need to create a triangle to help with this reference. I was given an angle. It's this one, 40 degrees south of west. So I'm going to draw in my components. I've got a component this way and a component that way. I am creating a triangle that could be used to find the components of my vector. As this is 200 kilometers an hour, I'm going to say this is opposite, this is adjacent, this is hypotenuse. We good so far? We have a way of dealing with a problem that has an angle and a side. I'm going to use my way of dealing with it. Sine of 40 is going to equal opposite over 200. Cosine of 40 is going to give me adjacent over 200. And I think I'm kind of done. Right? I don't have to worry about tangent. Tangent's going to is going to be the ratio of two sides I don't have. And I just need these two sides. So for the most part, I'm going to skip the steps I don't need. So it looks like this is going to be 128.6. And 153.2. I have found the adjacent and the opposite side. Now you guys in your notes, if you're just writing these numbers down, waste of time, right? Waste of time. Either you're doing this because you know how, or you're writing yourself notes about what to do. So be clear with yourself. Because here's what I'm going to do next. That's going to shift this a little bit. So are we okay with this? This is what we did yesterday. I'm adding to it now. We're going to be adding together like components. So I want to start keeping track of each vector's components. I've got the plane and I've got the wind. the plane will have components in the west-east direction and in the south-north direction, right? West-east is like saying the X direction, and south-north is like saying Y direction. We all good? So it appears in the west-east direction, I have 153.2 kilometers an hour for the plane. That's how fast it's traveling to the west. While at the same time, it's traveling 128.6 kilometers per hour to the south. I made west and south positive. There's other kinds of notation here. Some people would put like an X hat and a Y hat here. Has anybody seen this kind of notation? How about IJK notation? It just kind of corresponds with XYZ notation. It's just ways to identify the direction, because you can write vectors as a mathematical sentence. Like I could say the plane is 153.2 X hat plus 128.6 Y hat. X and Y represent unit vectors, but they're in opposite directions, so you can't add those two numbers together. This is a vector notation. It's not much different than having an ordered pair, 153.2, comma, 128.6. That's an ordered pair. Imaginary numbers, who's worked with those? Imaginary numbers are vector notation. I mean, right? It's the same thing. You are forcing your problem, your mathematical sentence, to have parts that represent different components. This is all just different ways to do so. In fact, this is related to e to the I theta. Another way you could write this all out, this would be 200 I to, you'd have to express your theta in radians, but basically 40 degrees. It's just another way of expressing vectors. There's lots of ways. So you guys are a little bit limited on your math, but there's just a lot out there. So don't think this is the only way this can be done. It's definitely not. All right, moving on. I have finished one of the vectors. I'm going to do the next vector. I don't want to spend a lot of time on this one. This one was intentionally easy because I wanted to be able to give you the gist of what you have to do. So again, coordinate system, south positive, west positive, north and east, and our vectors, the water, right? Due south. Oh, not the water, the wind, due south. And I believe it was 30 kilometers an hour. Is that right? I don't have to do much work here, right? It's kind of already broken up into just one component. There is no east-west component to the wind, so it's 0. But there is a north-south component to the wind, and it's in a positive direction as chosen by me. I have successfully converted all of my vectors from polar into rectangular. Step 1 done. Step 2, add together like components. So I have, just add down. These are like components, and these are like components. So this chart is just there to organize you. Again, not the only way to do it. It's just a way to do it. So 153.2 in the X hat direction plus 158.6 in the Y hat direction. I'm just using those to make sure you realize you can't add those two numbers together. They represent vectors. I could put 153.2 west, put a W there, and 158.6 south, put an S there. But I'm wanting to get you to recognize other kinds of symbology. Fair enough? We all okay? Not too big a stretch? Because that's step 2, it's all done. Whatever list of numbers you have there, that's what you would have. And this is our resultant vector. So that phrasing, resultant vector, is important to me a little bit, but not that much. Last step, convert your answer to polar. So all right, so I'm kind of pretty sure this is going to be a little off to the side, so I'm going to put that as west, south, east, north, positive, positive. So I have two vectors here. I have 153.2 in the east-west direction. And I have 158.6 in the north-south direction, producing a resultant like so. Now, when we've done this already, again, you're seeing there's a little bit of repetitive nature here, but this already defines a triangle. So I'm going to use the definition that's already here. I put them in this order. You didn't have to put them in this order. You could have done the 158 first and then the 153. I'm going to use this angle. I want to know this as well. So I need to work backwards, right? And by backwards, I mean kind of the opposite of what I just did. I'm going to start by recognizing I have the opposite and adjacent side. So tangent of my unknown angle is 158.6 over 153.2. I take the inverse tan or arctan of that ratio and get 46 degrees. Not quite done. I'm probably just going to use the Pythagorean theorem because it is pretty easy at this point. I get 221 kilometers per hour. 46 degrees. Not quite done. I should say that the ground speed is 221 kilometers per hour at an angle of 46 degrees south of west. Not terrible. Adding vectors together. I would still say that this is very procedural. Not a lot of thinking went into this. The only thinking was establishing a coordinate system and staying with a consistent coordinate system for positive and negative throughout the course of the problem. I'm not saying that you don't have to be in thought to do this. I'm just saying if you follow a procedure, you should be able to get to the answer. Now, we have 4 minutes left, which is not enough time for us to complete another full exercise like this. But I want you to be exposed to the nature of maybe some more challenging questions. So consider this as a more challenging question. And I'm going to use the word challenging kind of lightly here. I don't know how challenging this is. Imagine I have a river where the current is 3 meters per second. And let's say that the river is 50 meters across. There is a dock on this side of the river and a dock on this side of the river. And they are directly across from each other. I have a kayak. I can paddle 5 meters per second in still water. What direction should I aim my kayak so I travel directly across from one dock to the next? And how long will it take me to get there? I'll say all of it over again, because if you're writing the problem down, that's probably not a bad idea, so you have what the text would look like, because I would never provide this picture. There's a river that has a current of 3 meters per second. The distance between the banks is 50 meters. There are 2 docks directly across from each other. You wish to paddle from one dock to the other. You can paddle a boat at 5 meters per second. What angle do you have to angle your kayak in order to paddle directly across the river? Do you all have an idea of what this problem is like? Just to make sure that we all have at least a little bit of common sense, which is hardly ever common. Would I be turning towards A or towards B to paddle across the river? Do we all agree? You would try and paddle towards B? Okay, that's probably good. That's good. So just making sure. So I didn't change it up very much. I'm still going to start by putting a coordinate system in place. And I'm going to make that coordinate system aligned with the problem. I'm going to make this the X direction and this the Y direction. You know, there's the kayak and there's the water and there's the X direction and the Y direction. Do we all agree that the water is 3 meters per second in the Y and 0 in the X? Okay. How would you solve this problem? Try it. I'm going to post it. I'll finish it up and I'll post it.